Hello everyone. Welcome to this third session of solution of linear systems. Priorly, we discussed about homogeneous system of linear algebraic equations and one flowchart also we have drafted. I just repeat here once again what is the system, how it is converted to matrix notation and how to go for the solution. Now, in line with the non-homogeneous system of equations, we are considering here m linear equations and n unknowns, like the way you can see here: a11x1 plus a12x2 plus a13x3 plus and so on, a1n xn is equal to 0. The difference is that the right hand side is 0 for each of the equation. So we are having this is as the first equation, second equation, and this is mth equation. So m equations in terms of n variables we are having here, where all of these xi's are your unknowns or variables. A11, A12, and so on, Amn, these are the coefficients which further will form our coefficient matrix. And B1, B2, B3, and Bm, these are the constant terms which are all zeros here. Correct? So now consider the matrix form. So that's your coefficient matrix capital A, as we discussed earlier. This is matrix of unknowns and this is your right hand side matrix B. Now, if you can observe here, the entire matrix B, which is a column matrix, is all zero. So instead of B, sometimes some notebooks use the notation Z as well. So you can have the equation either Ax is equal to Z or Ax is equal to B, where B is entirely equal to 0. Alright. So notation is very similar one. And now the type of solutions we are having. So as we discussed earlier, the homogeneous systems are always consistent and will have only two type of solutions, either unique solution or infinite many solutions. Now, as I told you that if we are going to draft a augmented an augmented matrix over here, either this is a comma 0 or sometimes this is a comma b or sometimes this is a z. So how we are going to write down it? A11, A1n. I'm abbreviating here. This is AM1, AMN, and this is 0, 0, 0, and so on. So if you are recognizing here, the last column is entirely 0 and it will not contribute to rank. सो ये रैंक डिफाइन करने में कुछ भी कंट्रीब्यूट नहीं कर रहा है. सो रैंक डिफाइन कौन कर रहा है? ये पर्टिकुलर फॉर्मेट आपका रैंक डिफाइन कर रहा है, या ये पर्टिकुलर मैट्रिक्स कोएफिशिएंट मैट्रिक्स आपका रैंक डिफाइन कर रहा है. सो इसकी भी रैंक एंड इसकी भी रैंक ये हमेशा सेम होगी. देन व्हाई टू राइट डाउन all of these augmented matrix every time if it is homogeneous system of linear algebraic equations? It's all the way sufficient to get the rank of coefficient matrix only. So if we want a unique solution, coefficient matrix rank is equal to R and it must be equal to the number of variables, then we'll get unique solution. If we want infinitely many solutions, rank of your coefficient matrix must be equal to R, but it is less than number of variables. In that case, we'll get the infinitely many solutions. We also discussed earlier that unique solution for non-homogeneous system of linear algebraic equations is called as a trivial solution. And infinitely many solutions is called as non-trivial solution. So that two things we discussed earlier. Now the steps of solution is similar. Construct the matrix notation for the linear system, Ax equal to 0 or B or Z, whatever you want, right? Reduce the matrix A to echelon form, right? Then state the rank of the coefficient matrix and compare whether it is equal to number of variables or whether it is less than number of variables. On that basis, it may have trivial solution or it may have non-trivial solution. And if it is trivial solution, then all x1, x2, and so on xn, all variables are equal to 0. If it is not trivial, you need to find out the solution in terms of certain non-zero parameter t. If the parameter is 0, then we are heading towards the trivial solution. But as we arrived at the conclusion that rank of A will be equal to certain R, which is less than number of variables, system has to be a non-trivial solution, right? So T as a non-zero parameter sum we have to consider for this particular part. Now let us try to discuss the problems over here. Problem number 1. Solve the system if consistent. Now it's actually homogeneous system of equations and is always consistent. It is just to confuse you whether the system is consistent or not. But as it is homogeneous system, it is always consistent. So we are having four equations here. These four equations. Now let us draft the augmented matrix of coefficient, matrix of variables, right hand side matrix which is 0 here, and hence the augmented matrix A comma B or A comma Z, whatever way you want. Or as we discussed earlier, simply write down the coefficient matrix and get its rank. So our system we drafted in the matrix notation, and we are heading towards to write down the coefficient matrix, and hence further we will apply the echelon form to find out the rank. Now as we are having 1 at the position A11, these below elements can be made 0 by using the right operation. So twice R2 minus twice of R1. Now in this case, this row is our reference row. So we are not changing here, but with reference row, the rest of rows we are changing. R3 minus 4 times R1, R4 minus R1. So equivalent matrix will get in this way: 1, 2, 3, 0 minus 1 minus 5, 0 minus 3 minus 8. And here we'll get this is minus 1 and this is minus 5, right? So now performing further, we are having A to 2 position, which is minus 1, and below elements here we can make 0. So the certain operations is R3 minus 3 times R2, R4 minus R2. So ये दोनों भी elements यहाँ पे 0 हो गए. Correct? As we are having the last row, let me write down the last row here. This is 0 minus 1 minus 5. So last row and second row is similar. So R4 minus R2 gives you the entire last row as 0. Now as this is your coefficient matrix and we are performing here the row transformations only, you can observe here with these two operations our matrix is reduced to this one, where A33 position is a non-zero element. You can either keep it as a 7 or you can divide with 7, no issues at all. But here we can end up with our operations, and you can observe the step structure here, or we can observe how many number of non-zero rows are there. So non-zero rows are 3, so rank of coefficient matrix is equal to 3, which is equal to the number of variables. Hence the system will have trivial solution, and the trivial solution by default is equal to this one. Not needed to क्रॉस चेक इवन, बट अगर आप क्रॉस चेक करना चाहते हो तो यहां से आप सिस्टम बैक लिख सकते हो. दिस इज x plus 2y plus 3z is equal to 0. Then this is minus y minus 5z is equal to 0. And this is 7z is equal to 0. So this implies z is equal to 0. Substitute this in this equation, hence y will become 0. And substitute both of these in equation 1. In that way, x is equal to 0. So that's the solution of homogeneous system of linear algebraic equation, which is having trivial solution. Now let us come to the next problem. So again, the question is similar: solve the system if consistent. As it is homogeneous system, it will be consistent and will have either unique or infinite solution. means either trivial or non-trivial solution. So 3 equations we are having. Let us draft the system in terms of matrix form in this way. Coefficient matrix, matrix of unknowns, and right hand side matrix which is 0. Write down your coefficient matrix and start reducing it with using the row transformations only. So position A11 is already 1. Below elements can be made 0 with the help of these two operations. So below elements now 0. A22 position is -4. Below of that it's minus 8, which is multiple of -4. So the certain operation is R3 minus 2 times R2. So this position we are going to get 0. And you can observe here the last row is also equal to 0. Now observe the rank of the matrix, number of non-zero rows. Rank is equal to 2, which is less than number of variables, right? Hence, the system will have trivial or infinite solution, which is called as a non-trivial solution, right? Now, how to find out the solution from here? Now, write down the system back from this reduced matrix. This is x plus 3y plus 3z, x plus 3y plus z is equal to 0 and minus 4y minus 4z is equal to 0. Now once again, how many equations are there? 2. How many variables are there? 3. So how many number of independent variables are there? 3 minus 2, that is 1. Alright, so substitute z equal to t from this second equation. Either y or z you can substitute as t. Here we are substituting z equal to t. Hence, y will become 4, 4 or minus 4 will get cancelled. If z is equal to t, y will be also is equal to, y will be equal to minus of t, not t. Right? Substitute z equal to t, y equal to minus t in equation 1. So from here, equation 1 से हमें यहाँ पे मिलता है, this is minus t minus 3t plus t. So minus 2t, right hand side पे जाके हो जाएगा plus 2t. So x is equal to 2t. So this represents your non-trivial solution for the homogeneous system of linear algebraic equations. Correct? Unlike non-homogeneous system of equations where certain unknown constants were introduced either in coefficient matrix or in right hand side matrix, we can have the problem of unknown constants in homogeneous system as well. So you can observe here, these are the 3 equations where k represents the unknown constants, and here for this problem what we have to do is, for different values of k, discuss the nature of the following equations. Whether it is this system is having unique solution means trivial solution, or infinite solution means non-trivial solution. So that's our example number 3. Again, a methodology is similar. Form your matrix notation or Z, right? Get the coefficient matrix, reduce it by using the row transformation, and here with these 2 row transformations your system get converted to this, where A1 position is 1, A22 position is k plus 1, and A33 position is k minus 1. Now here case 1 we can discuss as system has unique solution. If we want a unique solution, both of the positions A22 and A33 should not be 0. Now k plus 1 should not equal to 0 and k minus 1 should not equal to 0. So what this together give us? K should not equal to plus 1 or minus 1. Right? So unique solution तभी possible है इस system को if k is any value other than 1 and minus 1. Next is case 2. System, your coefficient matrix A should have rank 2, which is less than 3, that is number of variables. And it is happen if k plus 1, either this has to be 0 or k minus 1, either this has to be 0, right? So k is equal to 1 जब है तब आपका यहाँ पर मैं बताती हूँ k equal to 1 है तो रो 3 आपकी 0 हो जाएगी and this will become 0 to 0, row 2. अगर k आपका -1 है, then it will become -2 and it will become 0. The second row will get 0 and third row will become 0, 0, minus of 2. Means either यहाँ पर आपका k is equal to -1 होना चाहिए या k equal to +1 होना चाहिए for infinite or non-trivial solution to the system. Alright, in both of the case आप यहाँ पर solution find out कर सकते. Now substitute once k is equal to 0, k is equal to 1 and write down your system. So this is nothing but the system of linear algebraic equations. So for k equal to 1, k equal to -1, we can write down the infinite solutions over here. And with this problem, we can conclude our discussion of solution of linear systems, including homogeneous, non-homogeneous, and all variety of types. Some problems are already posted on our classroom under this topic, linear systems, right? So please go through it and try to prepare the set of problems at your own. Thank you all.